Okay, so you can see here, I'm given a table right here. Today we're going to learn about first difference. So how do we calculate first difference? Is we subtract each number in the second column backwards. So this is your y column. So this is your x, this is your y. We're going to subtract the y's backwards. Okay, let me back up a little. Before you can subtract backwards, you have to check to make sure your x is in order. So 0, 1, 2, 3, 4, 5. So it's going up constantly by the same amount. Right? So, yep, this is in order, going up by ones. Now I can subtract my y value backwards. 40 minus 32, I get 8. 32 minus 24, I get 8. 8. 8. 8. Okay. So, describe what happens to her pay when the number of hours she worked increased by 1 hour. What is that 8? What does that 8 represent? $8 more specifically? $8 per hour, right? All right, take a look at the chart. Number of hours work and your pay. So if you don't work, you don't get paid. Makes sense. You work 1 hour, you get paid $8. Work 2 hours, you get paid $16. So when you do that first difference by subtracting backwards, you can see what the difference is between each hour. So it's $8 per hour. When the number of hours increase by 1, the pay increases by 8. Okay. Create a graph of pay versus number of hours. The plot suggests a linear or non-linear relation. Which one do you think? Linear, right? Because the first, since the first difference is this is your first difference column. Since the first difference is the same, this implies the graph is a line. And the relation is linear. Yeah, that's exactly, that's what this lesson is about. Today's lesson is calculating first difference in the chart. If the first difference is the same, you know that is a line and the relation is linear. Okay? So vice versa. If any one of these numbers is different, then it means it's nonlinear. Okay. To find a pattern in first difference, the value of the independent variable, the x, must change by a constant amount. So that's what we were checking first, if x goes up by the same amount. First difference is the linear relation. First difference of a linear relation are constant. First difference of a nonlinear relation are not constant. Okay. So try this one. Be careful with when you subtract. So here, first off, are my x going up constantly? Yep, going up by 1. So I can subtract my y value backwards. Negative 13 minus negative 10. Okay, what do you notice right here? Okay, the brackets, and also what about the sign? 2 negatives make a positive. So this is now negative 13 plus 10, which gives you negative 3. Let me zoom this in a bit more. Okay, so be very careful. Even though you think, oh, first difference is so easy, you're just subtracting. Be careful with the signs. Same thing right here. Negative 10, take away negative 7. All right, negative 10, take away negative 7. Again, the two negatives make it plus. So negative 10 plus 7 is negative 3. Okay. If you keep going, negative 7 minus negative 4, negative 3. Negative 4 to negative 1, negative 3. Here, negative 1 minus 2, negative 1 minus 2. What do you get? -1 minus 2, -3. Yeah. All right, so positive or negative, you do the same way, but just be careful with the signs. And then 2 minus 5, you also get -3. All right. Since all the first difference are the same, this is a linear. Not yet, we're doing a lesson right now. Okay, can you guys try this one? So first off, check the x value. Yep, it's in order. Do the first difference. Okay. So 14 minus 15, you get -1. 15 minus 15, what do you get? 0. Okay, just to check, did I do the math correctly for these two rows? 14 minus 15 is -1. 15 minus 15 is 0. So I don't have any mistake, right? Yeah. So as soon as my first difference is different, I know this is a nonlinear. So I don't need to waste time doing this part. As soon as one number is wrong, it's nonlinear. Right? And I know people make mistakes subtracting. So that's why I said, okay, I got a wrong number. I got a different number. Let me just double check to make sure I didn't subtract wrong. All right, so it wasn't me. That means this really is a nonlinear relation. All right, what about this one? All right, so just looking at this table, who says it's linear? All right, who says it's nonlinear? It has to be one or the other. Okay, let's ask that again. Looking at just this table right here, who says it's linear? Who says it's nonlinear? All right, yep, you are right. Linear it is. 5 minus 5, 0. 5 minus 5, 0. 0. 0, 0, 0, 0. So it's 0 for all of them. Yeah, 0 is still a number, and so it is linear. Okay. If I were to plot these points on a graph, what type of line will you see? Jasmine? Horizontal line. Yeah, that's right. So if you were to graph this, you actually get points like this. Okay, which makes a horizontal line. Okay, a horizontal line is still a line. You can have a vertical line, you can have a horizontal line. Okay, so let's try to write an equation for these linear relation. For grade 9, you will only know how to write the equations of lines. So we cannot write for this one. We can write for these two. Okay. You guys heard of y equals mx plus b? Oops, sorry. You guys heard of y equals mx plus b? Yeah, okay. We actually talked about it like a few days ago. Okay. The m is basically your first difference if your x goes up by once. Okay. Because your m is the change, the rate of change. So your difference in the y divided by your difference in your x. So what's my difference in the x right here? 1, right? So -3 divided by 1 is just -3. So that's why I was saying when your x goes up by 1, your m, your slope, your rate of change is just your first difference. Okay, so for this first equation, that means for this first relation, my equation is going to be y equal -3x. This plus b is my starting value. Looking at this chart, what's my starting value? Be very careful. What's my starting y value? Petro? -1. Good job. So not 5, just because this was the first row doesn't make it the starting value. Your starting is when x is 0. That's your y value. So my equation here, that. Okay. And we just built our first equation. Yay. Let's try this. Okay. Let's try this. So same thing, y equals mx plus b. So y equal, what's my m here? 0. 0x. And what's my starting value? 5. Right, just row right here. 0, 5. So plus 5. Okay. I think I can probably clean this up a little. What does this simplify to? Y equals 5. 0 times anything is 0. So that is just gone. So my equation for this relation is just y equals 5. Okay, so today's lesson, we're kind of like combining two ideas together in one. Later on, we'll have like a more formal lesson on equations of a line, but I think I want you guys to like get a sneak peek of equations first. Okay, on the back. Okay, it's a hot summer day and Roma is filling the pool with water. She placed the hose in the pool and noticed the height of the water each minute as shown in the table below. Fill in the first difference column. Okay. So, okay, I think you guys could do, I'm going to get you guys to try to do the next 2 page. I think you guys will do it. Yeah, all right, take, I would say 15 minutes. Take 15 minutes, try the next 2 page, and then we'll take it up together. Okay, so I think everybody got a chance to look at the first example. You guys were able to do that. I caught some mistakes walking around. So remember, first column, this first column is always your x, your independent variable. So first column goes to the bottom. All right. One mistake that I caught was, remember, the scaling is the most important part of a graph. So if you're skipping every 1 box, make sure you are skipping every 1 box. If you're skipping every 2 box, skip every 2 box between each number. You have to be consistent between numbers. So I don't forget the titles. So I plotted that, I gave the numbers, and then I drew my graph. Is this a 100% graph? Is this a perfect graph? All right. Petro says no. Dikshan says maybe. Okay, Petro, why not? Title, yes. Okay, later on you'll get an assignment, so make sure you have titles, title. So what's a good title? Y versus X. So it's height versus time. Height versus time of a wading pool. Something like that. Okay. Something like that. Remember, if you write time versus height, you're going to lose half a mark. It's always the Y against the X. Okay. So title, don't forget that. Second thing I don't like about this graph. There's one more thing I don't like about this graph. What I have right here, even though I drew it. Okay. What other thing would you change in this graph? Jasmine? It's okay. I don't need to label it XY because I did label it with the time and height already. So it's okay, not that. Something else I don't like about what I drew right here. Bella? Sorry, not Brianna? The line doesn't go all the way up, and not just up, but Yeah, both ends. Your line goes on forever. So don't stop at the first and the last point. Extend it out. All right, draw an arrow at the end. And remember this word problem. You're filling the pool with water. So thus your water magically get to 3 centimeters. Does the water level magically get to 3 centimeters? Magic holes. Okay, so no, it starts off at 0, 0. So this, don't just start it in midair. It actually starts from 0, 0 and goes up like this. Okay, so extend your graph to how it should. All right. Describe what the first difference tells you about the relationship. Well, we saw that first difference is 3, so include the units, 3 centimeters per minute. It's linear because first difference is the same. Simple as that. I'll ask you like 10 questions on the next test. Why is this linear? Why is this linear? Why is this linear? And one of the reason, you can just simply say because first difference is the same. Okay. Make a scatter plot and draw the line of best fit. Scatter plot just means a graph with points, which we have here, points. And then if we connect it, now it becomes a line of best fit. Does the graph support your answer? Yes, because again, first difference is the same. The graph shows a line, therefore it's linear. Everything matches. Okay, so Naomi, you can help me with this part. Write an equation. So remember, your equation is in the form y equals mx plus b. What's my m? Yeah, my m is 3. What's b? Where did you get 0 from? I don't see 0 in my chart.
The b has to be 0, and then the x has to be 0, and then the y has to be a number. And for this case, it doesn't show 0. So.
Yeah. So remember, first difference is the constant amount that y is increasing. So if you go backward one more row, that means 3 minus 3, it starts off with 0. Yeah, so your starting value is not 1 and 3. Again, water doesn't magically appear at 3 centimeters. So it's 0, 0 if you go backward one row. EQAO love to ask that, where you have to go backwards one more row or 5 rows and so forth. So keep that in mind. Even though your table doesn't show it, sometimes you have to go backwards yourself. Okay, so b is 0. So therefore, giving us the equation y equals 3x plus 0, or simply y equals 3x. Okay. How long does it take for the water in the pool to be 7 centimeters deep? So based on your graph, 7 centimeter. So 7 centimeter deep, meaning I'm looking at my y values, the height, at 7 right here. That. I'm going to draw a dotted line to my line, and then draw a dotted line down. So it looks like it takes about how long? How long does it look like it's going to take? Roughly? Sean? Huh? Okay, it's 2 minutes, 20 seconds, or roughly 2.5 minutes. All right, that was very precise. Okay, so if you write like around 2.5 minutes, that's fine. It's close enough. Okay. What about 30 centimeters? So 30 centimeters, but my graph only goes up to 21. So what should I do? What should I do? My graph only goes up to 21. Yeah. Extend it. Yeah. So 18, 21, 24, 27, 30. There you go. Draw a dotted line across. So for 30 centimeter, I'm going to draw a dotted line across to my line of best fit, and then draw it down. All right, so based on that, On the test, I might ask to see this. So to show your work, you're drawing these dotted lines on your graph. So how long is it going to take for it to reach 30 centimeters? 10 minutes. That's right. 10 minutes. It's a word problem. Don't forget units. If you forget units, half a mark off. Okay. Next part, it was asking interpolation, extrapolation. Oh, yep. Sorry. So 2.5 minutes and 10 minutes. Okay. So some of you were asking about these two words. Interpolation. What's the word that you see within this word? Inter. What does inter mean? Like within. So within your graph. And extrapolation, what word do you see in this word? Extra. So outside your graph. Alright, so that's what it means. I might ask you about these two terms on the test because we use that a lot in grade 10. Okay, so for 7 centimeters, it was within your graph. So this is interpolation. You were able to base it on the data that you collected. And this one, 30 centimeters, it is extrapolation because you have to extend your line. Which is more accurate, interpolation or extrapolation? Interpolation, because you got data on it. You have data to support. Extrapolation is not really is not the most accurate because your pool may only go up to 25 centimeters, for example, right? You don't know what happens beyond that. It's full. Okay. Have you guys done this? Do you guys need another minute or we can take it up? Take it up? Okay. So, first difference in this case. Alright? This goes, so some mole, is growing. And you decided to record the amount of mole that's growing per day. Yeah. Okay. So first off, time is going up by days constantly. So that's good. So we can do our first difference. 640 minus 320. What do you get? 320. 320 minus 160. 320 minus 160. Addition? 160. Yeah. 160 minus 80. 80. 80 minus 40. 40. Okay. Looking at this right here, I see a pattern. But do we care about patterns? No, we care if it's the same or not. So, describe the first difference. What it tells you about the relation. Sorry? Nonlinear. So it's a nonlinear relation because first difference is different or not the same. Okay, as weird as it sounds, that's all you have to write on the test because first difference is different. Okay, drawing my graph. Time goes on the bottom with days. Amount with grams. Give it a nice title. Amount versus time. Amount of mole versus time. Okay. Or you can say the mole growth daily. or daily mole growth. Okay, something like that, as long as I get a meaningful title. Okay, 0. Since I'm going 5 days only, I can do 1, 2, 3, 4, 5, skipping every 2 blocks. For the amount, what should I go up by? What's a good scale? Sorry?
60, skipping.
Okay, go by 60s. Sure. Do we like that? So Petro says go up by 60s. We could.
100.
Oh, 160. Oh, sorry.
So go up by 80.
Okay. Do we like 160? Okay, so why did you choose 160 and not 50 or 100?
Because I see a pattern that all of them are I don't know how to explain it, but they're all multiple of 4. So
Okay.
160 is
Okay, so not bad. But if I go 160, these 2 points are gonna look really tiny. Like I have to squish in 40 and 60 within a box. So I'm thinking 160 is a little too aggressive. 80, yeah, 80, that means up to 640, I need about 8 bucks. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, not bad. I might be able to do 60, but let's do 80. So 80. Okay, so I went up by 80. Right, per square. Okay, so how I got that scale is because I looked at my y value. I had to go all the way up to 640. So that's why I chose 80. If I chose 20, for example, I'm not going to have enough room. If I chose 200 per box, my graph is going to be all squished. So take a moment to think about your scale because that's the most important part in a graph. All right, so 1 and 40, 2 and 80, 3 and 160, 4 and 320, 5 and 640. Okay, how should I connect these dots? Cindy? Curve, good job. No line. And I know no line because my first difference was different. So, 1 smooth curve with an arrow at the end and this. How should I draw this part? Should I draw it all the way down here to the negatives? No. All right. The mole starts off with 0 again, like this. So it should look something like that. Your mole doesn't become negative amount, and there's no negative days. Okay, so we made a curve of best fit. Does your graph support your answer? Yes. Why? Because first difference not the same. And so we should get a curve, which means non-linear. Okay. EQAO loves to ask these questions. All right. So keep that in mind. How to answer these ones. So based on your graph, 100 grams of mole means right here, about right here. 100 is about right here. So going across to your curve, and then coming down. Roughly, how long is it gonna take? 2.5 days. Good. And days, not minutes. 2.5 days. Alright. And then 1,000 gram of mole. Again, means that I have to extend my graph. So, 880, 960, and then this will be 1020. Okay, so if I keep going, if I extend my graph, go across, and then come down. Okay. Okay, something like this. I extend my graph. How long is it gonna take? How long does it look like it's gonna take? Alright. Yeah, Pedro?
5 days at 5.5 days.
5.5 days? Yeah.
5 days and 13 hours.
Okay. If you that's like a level 5 answer. Good. Okay. If because this is an assumption, if you just write around 6 days, it's fine. As long as you don't say 5 days, because at 5 days we know it's at 640. So somewhere between like 5.5 or 6, you'll get the mark on the test. Okay, and you can see based on this, it's gonna take around 5.5 to 6 days. 5.5 to 6 days. Okay, so any question on today's lesson? Okay, so I think it's pretty straightforward. You have 15 minutes now to start on your homework. It's just these 4 questions right here. Question 4 is a challenging one. You can try it. I only gave you 4 numbers in the whole chart, but it's enough to fill out the whole chart. So do try it out. For each of these that you could do a linear relation, try to write the equation as well. Okay, so if it's linear, try to write the equation. Okay, and then we'll take this up beginning of class tomorrow.